Hi guys, so today we're going to be talking more in detail about graphing polynomial functions. So this isn't actually something that's covered in your book for some reason, but I think for many newer Algebra 2 books and for a rigorous and complete Algebra 2 curriculum, you should probably learn at least how to sketch and get a general idea of graphing polynomial functions. We saw that a little bit when we did analyzing polynomial functions, but now that we actually know how to find zeros and stuff like that, that's going to help us a lot more to get a more accurate graph. So the first part really is just some information that's important to know. So the graphs of polynomial functions, they are continuous, which means that you can draw the entire thing without lifting your pencil from your paper. Okay? It should be smooth in the sense that it means that it doesn't have any holes, which we'll see later with rational functions, any breaks, or any sharp points or corners. The hills or the valleys where the graph changes direction from increasing to decreasing or from decreasing to increasing are often called turning points. We saw that with our relative maximum and relative minimum, okay? And the number of turning points is never more than the degree of the polynomial minus 1. Okay? If the degree is n, the number of turning points is at most n minus 1, right? So we see that with our quadratic, it's a degree of 2, and here we only have 1 turning point. Okay? The real numbers that create the roots or the zeros of a polynomial we know correspond to the x-intercept. We've seen that in the past couple of days. Okay? And the number of times a root or zero appears is referred to as its multiplicity. And what the multiplicity of a root or zero does is it determines the behavior of the graph when it reaches that point. Okay? When the multiplicity is even, if it shows up 2, 4, 6, 8, etc. times, it will just touch it or it'll bounce at that point, right? And so we see that here with x minus 2, right? It's repeated as a factor, so x equals 2 is a repeated root. It's repeated twice, and so that's why here at 2, it bounces there. It hits the 2 and then bounces back up, okay? Right? Versus when the multiplicity is odd, so 1, 3, 5, 7, etc. When it's odd, then what it will do is it will cross at that point. And so here we see x plus 1 as a factor, okay, x equals negative 1, and it only appears one time, which is why at negative 1 it goes through it. Okay? In addition to that, if the multiplicity is 3 or more and it's odd, okay, so 3, 5, 7, etc., then what it will do is the graph will show a flexing and a flattening as it crosses that point, right? So here with this polynomial, we see that x minus 1 is a factor 3 times, and so x equals 1 as a root happens 3 times, and so at 1, you can see it kind of flattens out. It still goes through it, okay, but it looks a little bit flatter compared to when it only appeared once. Okay, so this is just an example of what it explained in terms of multiplicity. Okay. Then the next part that kind of helps us graph is knowing the degree of the polynomial and the sign. We saw that previously in analyzing as well as when we looked at polynomial functions here. And the reason why is because it describes the end behavior of the graph. Right? We know that when it's an even degree, they're going to both go the same way. So in this case, both going up or both going down. The only difference is whether the leading coefficient is positive or negative. If it's positive, both ends are up, and if it's negative, both ends are down. Different from our odd degree polynomial where they're going to be opposite. One's going to go up, the other one's going to go down. One's going to go up, the other one's going to go down. If the leading coefficient is positive, then it's the right one that goes up. If the leading coefficient is negative, then it's the left one that goes up. Right? And so as we're graphing our polynomial functions, these are our steps. We're going to find our real zeros as well as our y-intercept. That's easy because that's our constant. Okay? We're going to plot these intercepts. And then if we need a more clear picture, we're going to make a table for several of our x values on it, plot those points from our table, and then use our end behavior to sketch that graph. Okay, so let's get started with 5x cubed plus x squared minus 5x minus 1. So we're going to ignore this part, okay? So here, positive zeros, I know I have 1. So positive zeros, I'm going to have 1. Negative zeros here, right? Because it's going to be f of negative x, right? That determines my negative zeros. It's going to be negative 5x cubed plus x squared plus 5x minus 1. Then I will have 2 negative zeros or 0. And then imaginary wise, okay, if it's 1 positive, 2 negatives, then it will be 0 imaginary. Or if it's 1 positive and 0 negatives, then it'll be 2 imaginary. Because in total, I need 3 zeros. Okay, so then, using that, let's test some points. So possible rational zeros, factors of 1 is 1. Factors of 5 is 1 and 5. Okay, so let's test 1 and negative 1. Or 1 first and then negative 1. Okay, so negative 5x cubed, 1x squared, 5x minus 1. So let's test 1. Okay, let's drop it. Negative 5 times 1 is negative 5. Add these together is negative 4. 1 times negative 4 is negative 4. Add these together is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. So that's perfect. 1 is one of my zeros. Okay. This then gives me negative 5x squared minus 4x plus 1. Okay. Let's see. I'm going to factor, attempt to factor. So negative 5x and x, since it's both positive. So positive 1 and positive 1. Okay. So then this is negative 5x plus 1 equals 0 and x plus 1 equals 0. This gives me x equals 1/5. Hold on, does this work? X negative x, yeah. And then the other one is x equals negative 1. Oh, hold on, sorry. I used this one. I should have used f of x. Let's scratch that. Start over. Okay. So it's 5, positive 1, negative 5, and negative 1. Okay. So let's try one. See if it actually works with this one. Because that was f of negative x. I want f of x, right? So drop the 5. 1 times 5 is 5. This is 6. This is 6. 1, 1. Okay, so it still works. So this is 5x squared plus 6x plus 1. Now if I factor this is plus 1 plus 1. So that means 5x plus 1 equals 0 and x plus 1 equals 0. This gives me 5x equals negative 1, so x equals negative 1/5. This one is x equals negative 1. Okay, so my first step is to find the real zeros and y-intercepts of the function. So my zeros is positive 1, negative 1/5, and negative 1, which works out perfectly, right? Because I have 1 positive 0 here and 2 negative ones. Okay, so I'm going to plot that. So I have 1 at 1, negative 1, and negative 1/5. They all only happen one time, so that means I'm going to go through each of them, okay, versus bouncing at it. My y-intercept is at negative 1, so y-intercept here is at negative 1. Okay. Then I'm going to just make a table for some of my other numbers here. So I'm going to try negative 2, and maybe 1/2 is between here and here, so 1/2. And I'm going to try 2. That gives me negative 27 for this. Negative 2.6, I think, for that one. And 33. Okay, so then both of these don't fit. So what that means, again, then knowing my end behavior, okay, this is odd. My leading coefficient is positive. So that means it's going to go this side and this side. So that means here, I know I'm going to go down here, right? Then I'm going to go through this 0. I'm going to go through this 0. I'm going to hit my y-intercept. I'm going to go through this 0. And then 233. Then it's going to go up here. So this is my graph. Okay, so why don't you try the next one on your own and then come check your answer when you're done. Okay, your graph should look something like this. Your zeros would have been 1, negative 1/4, and negative 1 based on testing them. Okay, so then I would have plotted those 1, negative 1/4, and negative 1. Your y-intercept's at negative 1. It's odd, leading coefficient is positive, right? So on the left side, you should be going down. On the right side, you should be going up. And then you can kind of just connect those, right? If you want it to be more accurate, you could do a table to get more exact points, right? But this kind of gives you a good shape of what it looks like. It just depends on where your max and minimum are to kind of give you that. Okay, so that's it for today. Have a great rest of the day. Bye, guys.